Go over kinematics, and I've got some work just from the Walker book. I've just used their table that you've got a copy of because that's a nice way of setting it up. So we're looking at these three terms: displacement, velocity, acceleration, and the graphs of these terms. If we graph time against displacement or movement, the steepness of that graph gives me velocity. If I graph velocity against time, the steepness or the gradient of that graph gives me acceleration. So if I want to work this way across, I'm differentiating, differentiation, differentiation. If I want to go the other way, if I know a bit about acceleration and want to talk velocity, anti-differentiation, anti-differentiation from velocity using S for displacement. I've got a link here to my graph, which I've got here, parts of the information ready to go. Now, I've picked this question because it starts in the middle at velocity, so we're going to have to differentiate to talk acceleration. We're going to have to integrate to talk displacement. Given it's a missile being fired vertically, so maybe it's like a rocket launch, and you've got a velocity equation that is that. So we start off, and I've fiddled with the axes here and set them up because I know where I'm going. But I've got a velocity graph. So it starts at 0, peak velocity here, and then it's actually got 0 velocity, and then it actually goes into negative velocity. So keep that in mind. So we're given that. Well, now we've got to find the following. So the first question is in the form that we're given. So we're asked about velocity. We have an equation. It's after 2 seconds. Time is in 2. So I just plug it in, and I got 216. Now, I've put a heap of coordinates on here. So that's that point there. So at time equals 2, the velocity is exactly 216. So that's matching. Initial acceleration. Now, there's two important things here. Initial means time is 0. Immediately, I guess, before the rocket is launched is the best way to think of that. And acceleration, and that's where we're going to go here. I know about velocity. I've got to differentiate to get acceleration. So, first of all, acceleration, and I might put a CC there, equals the derivative of velocity in terms of or using t. I'm missing an O there, so I'll pop it in. So, and I've started with that. The 120t comes to 120, 2 comes down to the front, 12t. Initially, t equals 0. So when t equals 0, the 12t doesn't come to much or anything. So the acceleration at that time is 120. And in fact, the acceleration at any time is that. And it should be a negative, because so if I put, so now I've got an equation for the acceleration. If I add that in, so there's its acceleration is peak. It accelerates to here. The acceleration is 0 at that point where the velocity peaks. And when the velocity drops off, the acceleration goes into decrease. So that acceleration line makes sense. It matches. Find the maximum velocity. So this is when acceleration equals 0. We've just got an equation for acceleration here. So we can make it equal to 0. A little bit of algebra. T equals 10 would make that equal to 0. So at t equals 10, what is the velocity? 120 times 10 minus 6 times 10 squared. That gives me 600 meters squared. Meters, not squared, per second. Apologies. So if I go to my graph, and I missed a coordinate. So if I go at 10 and 600, so that's my velocity peaking there at 10 seconds in, 600 maximum velocity, as fast as it goes. Peak speed. Okay. See now, when the missile find when the missile begins to fall to Earth. This is the high point, so that's when velocity equals 0. So this is going to be, so I've got velocity equation, when does it equal 0? Because this is when it's been going up with a speed, it diminishes, it's basically at a stall and then starts to drop. So velocity is 0. To factorize, t equals 0 I won't use, it's not practical. T equals 20, that looks good. So 20 seconds is when the rocket is at its maximum height and begins to fall. Okay, it's as high as it's going to get. Okay, now we've got to find the maximum height. Now we've got the 20 seconds, so we know when it happens, but what will it be? To find the maximum height, we need the displacement. We integrate to get displacement. If we go quickly back to here, I've got a velocity equation, but my question is asking me about displacement, anti-differentiation. Our friend integration will get us there. So, integrate velocity here. Let's put my equation in, throw it in the rules. Power going up by 1, dividing by the new power. Now, a generator plus C, but if we're talking initially, the rocket is right at ground level. So when t equals 0, we want displacement to equal 0. So C has to equal 0, or it would muck it up and it would have the rocket hovering off the ground. So displacement, the C is 0, that's our equation. We know from the previous question that the maximum height was found at 20 seconds, so we sub that in and we get 800 meters. Now, if I go back, no, not 800 meters, apologies, that's 8,000 meters, that's actually quite high. And if I go back and put the displacement equation in, you'll see that a couple of points of significance. There's the maximum height that the rocket gets to. 20 seconds in, it's at 8,000 meters. Another point that's significant is that here, 10 seconds in, that's when that blue line should be at its maximum steepness, because the velocity is at its highest point at 10 seconds, and it's hard to pick from the difference from here to here. You can see it's starting to taper, but that would be a point of inflection there, and that is actually the steepest point between 0 and 20. Okay, so when we're dealing with these, it's quite good to think of the graphical side, because it's the relationship between the gradient of this gives that, the gradient of this gives that, and those relationships. We need to have this table basically in our minds. Moving this way, we're differentiating, working on the gradient. Moving this way, we're anti-differentiating, and we're using information like initial values to find the value of C so we can complete. So going this way is always a bit more complicated because we generate a C. Okay.